Now I'll be explaining step by step how this Arduino code works. This code controls 3 LEDs, red, yellow and green, and makes them blink on and off at the same time. At the very beginning, we see these 3 lines: define R10, define G11, define Y12. What this does is give name to the pin numbers on the Arduino board. Pin 10 will be for the red LED, pin 11 for the green LED, and pin 12 for the yellow LED. This makes the code easier to read. Instead of writing just numbers like 10, 11 or 12 everywhere, we can use meaningful names like R, G and Y. Next, we have this line, UINT8 pins 3 equals to R, Y, G. Here we create an array called pins. This is basically a small list that stores all the LED pin numbers in one place. So now instead of writing separate code for each LED, we can look through this array and control them together. Then we have some variables. Unsigned long previous time equals to 0, unsigned long interval equals to 1000, INT LED state equals to loop. Previous time is used to remember the last time we changed the LED state. Interval is set to 1000, which means 1000 milliseconds or 1 second. So the LEDs will change every second. LED state start at low, which means the LEDs are off at the beginning. In the setup function, we have for UINT8, I equals to 0, I less than 3, I plus plus. Pin mode, pins I, output. This loop goes through each pin in the pins array and set it as an output. That way, the Arduino knows that these pins will be used to send signals to the LEDs, turning them on or off. Now, let's look at the loop function, which runs continuously. First, we get the current time in milliseconds. Unsigned long current time equals to millis. The millis function tells us how many milliseconds have passed since the Arduino start running. Then we check if enough time has passed to change the LEDs. If current time minus previous time more than or equal to interval, previous time equals to current time. So this means compare the current time with the last time we changed the LEDs. If at least 1000 milliseconds or 1 second has passed, then update the LEDs. We also reset previous time to the new time. Inside the if statement, we have LED state equals to LED state low, high, low. This line is a shortcut way of saying the LEDs are currently off, turn them on. Otherwise, if they are on, turn them off. So basically, it toggles the LEDs every second. Finally, we have another loop for UINT8, J equals to 0, J less than 3, J plus plus. Digital write, pins J, LED state. This loop goes through all 3 LEDs and write the same state to each one. So if LED state is high, all 3 LEDs turn on. If LED state is low, all 3 LEDs turn off. Lastly, we compile and copy the hex code to the simulation Arduino board in protest.
Boom, 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 boom. I want you in my room. Let's spend the night together from now until forever.
Hello everyone, today I'm going to explain for task 2 step by step how this Arduino program works. This sketch is designed to control 3 LEDs and also make use of an infrared sensor. 2 of the LEDs blink independently, each with its own timer, while the third LED lights up only when the infrared sensor detects something. By the end of this explanation, you'll understand how arrays, timing with the millis function, and sensor input are combined together to create a responsive and efficient program. Let's go through it part by part. At the very beginning, we have 4 lines. Define D11, pin 11, define D12, pin 12, define D13, pin 13, define IR, pin 2. This section assigns meaningful names to the Arduino pins. Instead of remembering that pin 11 is for one LED, we can just call it D11, pin 12 is called D12, pin 13 is called D13, and pin 2 is labeled as IR because it is connected to the infrared sensor. Using names like this makes the code much easier to read. So next we have this line, which is UINT8 pins 3 equals to D11, D12, and D13. Here the 3 LED pins are grouped into an array called pins. This allows us to look through them later instead of writing separate setup code for each LED. Arrays help us keep the program shorter, neater, and easier to scale up if we add more LEDs in the future. After that, the program set up timing variable, which is unsigned long previous time 11 equals to 0, unsigned long previous time 13 equals to 0, unsigned long interval 11 equals to 1000, and unsigned long interval 13 equals to 1000. The variable previous time 11 and previous time 13 are used to remember the last time each LED changed state. The 2 interval variables are set to 1000 milliseconds, which equals 1 second. This means both LED will blink once every second, but since each has its own timer, they work independently. Next, the program sets up variable to store the current state of the LEDs, which is INT LED state 11 equals to low and INT LED state 13 equals to low. This start as low, which means both LED are off at the beginning. The program will flip the states back and forth as it runs, turning the LEDs on and off. Now we come to the setup function. For UINT8, I equals to 0, I less than 3, I plus plus, pin mode, pins I output, and pin mode IR input. Here, a loop goes through the pins array and set each LED pins as an output, which means the Arduino can send signal to them. Then the IR pin is set as an input, which allows the Arduino to receive signal from the infrared sensor. Inside the main loop, the first line is unsigned long current time equals to millis. The millis function gives us the number of milliseconds since the Arduino start running. This is like having a stopwatch that starts when the Arduino is powered on. By using millis, we can measure time without pausing the whole program, unlike delay, which would freeze everything. Next, we have the first LED blinking logic. If current time minus previous time 11 more than or equal to interval 11, previous time 11 equals to current time, LED state 11 equals to LED state low, height low, digital right D11, LED state 11. Here's what happened. The program checks if 1 second has passed since LED 11 last changed. If yes, it updates the previous time 11 to the current time. Toggles the LED state. If it was off, turn it on. If it was on, turn it off. And finally, writes that new state to pin D11. This makes LED 11 blink on and off every second. The same structure is repeated for LED 13. If current time minus previous time 13 more than or equal to interval 13, previous time 13 equals to current time. LED state 13 equals to LED state 13 low, height low, digital right D13, LED state 13. This section works exactly like LED 11 but use its own timer. The important detail is that because LED 11 and LED 13 have independent timers, they don't interfere with each other. Even though both are set to blink every second, here we could easily change one of the intervals. For example, make LED 11 blink every second and LED 13 blink every half second. Finally, the program checks the IR sensor. If digital read IR equals to high, digital write D12 high, else digital write D12 low. This means the Arduino looks at the input from the infrared sensor. If the sensor sends a high signal, that means it detected something and the program turns on LED 12. If no detection happens, the LED stays off. So LED 12 is an indicator light that reflects the IR sensor status. Lastly, we compile the file and copy the hex code to the simulation Arduino board in Proteus.